let's cover a few really common logical errors that we get as well. And the first one we're going to do is when you mix up less than or greater than or equal to, because they will all do something different. And if you get the wrong one, then it won't do what you expect it to. And there's two barriers here that you often for people. First is just remembering which one's less than and which one's greater than. And then after that, it's remembering that there's such a thing as less than or equal to, different sign as well. And you need to check what your if statement is doing. So let's just give an example for this. Let's set a variable. Let's just have a number. Let's do that. Set to 10. And then our if statement here, so our algorithm here, is going to be checking if my num is 10 or lower. Okay, that's the goal of the algorithm. And if it is, it's going to print out 10 or lower. Okay, so 10 or lower, that's the purpose of it. All right, and I'm hoping you're immediately spotting a problem with that. I'm hoping you're immediately spotting with the if statement here, because if you know your less thans and greater thans and you need to come up with a method, it could be that, the whole idea that crocodile's eating a larger number because it's hungry, or I use the one where I just stick my hands out in front of me and see with my thumb and forefinger do the letter L or not, to which one's greater than or less than. But you need to remember which one's greater than or less than. In this case here, I've got it the wrong way round. So this is checking to see if my num is greater than 10, not if it's less than 10. Whoops, you might have spotted there. I did a syntax error. Look, see, even when you're writing, I didn't put that closing bracket in. Right, so just back to this one. So that is the wrong way round. So you might fix that. You might think, okay, great, I'll just swap that round, all done. No, don't need to worry anymore. No, actually haven't actually fixed that algorithm yet, because what if the number is 10 like it is here? This algorithm's meant to say if it's 10 or lower, and this will only work, this if statement will only fire if my num is less than 10, not less than or equal to 10, which is what we need. So there is a different whole set of signs, which is less than equal to, which is just as it sounds. So if you want less than and equal to, you do a less than symbol and then you do an equal to symbol, and if it was greater than and equal to, you'd obviously just reverse that sign there. So that if statement will check to see if a number is less than or equal to a value. Make sure you know which sign you need to use, and it all depends on what your algorithm should be doing. Okay, so that's a really common one. Next one we're going to do is overwriting variables accidentally, and this can be caused by one or two things. It could be just that you get muddled up in your variable names, or it could be sort of something around swapping a variable, which we'll cover here. So let's do this. We'll do first num and we'll do second num. And then you might be tempted, if you want to just swap these numbers around, so you want to put 11 in first num and 7 in second num, you might be tempted to do something like this. So first num equals second num, and second num equals first num. Now you might... And if you do that, you will not swap the variables over, but you will overwrite them, and you will, basically lose some data, which is not what you want to do. I'm just going to run through that algorithm very quickly using the idea of variables with boxes with values in them. So this is going to be first num, this is going to be second num, and let's get going with it. Let's do this line here. So that's going to set first num to 7. Moving on to here, second num is going to become 11. First num is going to become second num. What's in second num? It's 11. So first num is going to be set to 11. And oh dear, I think you see the problem. We've lost the number 7 already somewhere. So when I come here, second num equals first num. Okay, but that's just going to put the number 11, which is there, back into there. So I've lost the number 7 along the way. The way you would fix this, just so you're aware, is have a temporary variable. So you do something like this. You'd have temp equals, there's a couple of ways around you can do it, but let's do it this way. So temp equals first num equals second num, and then second num would equal temp. And if you work that through, that would be 7, that would be 11. Temp would then become 7, first num would become second num. So if we have a look here, first num is it's currently 7, we get rid of that. And then second num's got the value 11, so that would come in there. And then second num becomes temp, which has the number 7 in it, which is what we want. So being able to keep track of what's in variables and not overwriting variables is very important. That is a common sort of logical error to fall into, where you accidentally do that, or you don't get your variables quite right, and you end up overwriting some data. And having that temporary variable is really useful if you're swapping numbers. Last logical error that is very, very common. Actually, this will demonstrate a couple now I think about it, but it's all about for loops and the number of times they are repeated. And it really doesn't help that some programming languages are a little bit different at how they implement for loops, but I'm going to show you what's used particularly in exams, so there's no sort of confusion. Now, if you imagine you have an algorithm whose purpose is to give you an average of 5 numbers which are entered. So I'm just going to quickly write this out now. You would ask for input, you'd add that to some sort of total, you'd move on, and then you'd print out whatever the total is divided by 5. Okay, there's 2 problems with this, and actually they're both quite common. So see if you can spot the 2 logic errors. The first one is I'm not actually successfully adding to my total here. His total equals none will not add on to an existing total. It will replace what's in total each time. So you need to be aware of this sort of programming trick that I can do this. Total equals total plus num. Okay, if I do that, I'm adding on to what's already in total rather than replacing it each time. So you can use that like a running total. The second thing is, and really what I wanted to talk about is this. For x equals 0 to 5, hold out your fingers in front of you and let's count out how many numbers there are between 0 and 5, including those numbers. So 0, 1, 2, 3, 4, 5. How many fingers have you got held up? It should be 6, because you counted 0, and you should count 0, and because that's what computers do. They will count that 0. So it's tempting to see this higher number here when you're dealing with 0 and just sort of think it will only do it 5 times. It won't. It will do it 6. Zeros are important to computers. So there's a couple ways to fix this. Obviously, you could do either x equals 1 to 5. That would work. But if I'm honest, that kind of runs you into problems when you're doing coding later with things called arrays and stuff. So what is the more common solution is this. If you want a loop to repeat 5 times, you would do 0 to 4. So there are some really common logical errors that you find with algorithms. So if you're given an algorithm as an exam question, you're told it's got problems in, chances are at least one of these issues will be present. So now you know what to look for. If you found that video useful, please hit the like button and hit subscribe to the channel. Keep learning and revising more computer science by clicking on the videos linked here.